Good afternoon, everyone. My name is James Jau. It's my pleasure to introduce to you about our new product. We call that the Scale-Out Inference Hardware Architecture. We all know, over the past few years, thanks to Jeffrey Hinton's great success in the ImageNet competition in year 2012. After that, deep learning started to draw our attention. Today, almost every chip vendor has their own solution that can shorten the time spending on training a model. We are all familiar with these training servers like NVIDIA DGX-1 and Facebook BigBasin. Actually, those two servers are designed and manufactured by our company, QCT. The horsepower of this hardware is the essential fuel for AI boom. We all know user experience is crucial to customer satisfaction. Talking about AI, how does deep learning help your service feel more intelligent? How would users know and feel that your service is intelligent? Well, that's inference. Inference complete the AI. Okay, let's take a look at the hardware focal point design for training and then inference. Inference is an important step that the influence user experience and whether they can enjoy AI benefit. Like I mentioned earlier, today, we are all familiar with the hardware architecture for training, which requires synchronizing parameters between multiple GPUs. So that's why we all know in DGX-1, there is a high-speed NVLink to help expedite the process among those A GPU. Scale-up design today still dominate training and require large data set and higher numerical precision. But unlike training, we don't need that powerful accelerators with high thermal envelopes like V100 to do inference. Inference does not need the horsepower. Inference can scale out as small individual tasks running on multiple servers, which can lower the cost of delivering inference. We can use lower power, like NVIDIA T4 GPU, which is only 75 watts. Or we can use Intel Area 10 FPGA to do inference very well. And we have also benchmarked the accelerator performance on Intel Xeon E5 and the E3 with GPU, and our findings are that the CPU capability does not really affect the inference performance very much. Of course, this is based on our workload. Different workload may require different CPU performance. So this is more detail on our system architecture. So based on the scale-out concept, we create our X11C. This is a 2U4 node system based on the Intel Xeon E3 processor. This is a 2U chassis. that integrate 8 slates into this chassis. And this is a very flexible design architecture. Later, you will see there are many different skills, different mix and match to serve different workloads. As you can see, we offer different slates, which we will take a closer look at that later. You can see the different configuration here. We can have a pure CPU, only Intel E3 CPU, or one CPU with one GPU or FPGA together with the CPU. Or even we provide a slate, which can accommodate 2 accelerators. So one CPU can integrate with 3 accelerators at the maximum. With those multiple accelerators, we can only install 4 nodes. That becomes 2U 4 nodes. So in brief, each slate can be CPU plus accelerator or pure accelerators. So this is a very flexible design. This is a system exporter view. Here you can see the system with the slate at the front. The machine is just on this table. Maybe after, we may reserve a couple minutes after my presentation, so you can come and take a look. And the one middle plane, and of course, redundant cooling, redundant power with network module at the back of the system. So this is a real view. See, you have power supply, you have a cooling fan. We also have, they are all hot swappable. Also, we have a simplified design with network module to aggregate all 8 nodes networking in the rear to reduce cable management and save the Tor switch cost. So this is another view of the slate. So we offer a PCI slot for each compute node. So we can allow one CPU with one accelerator, totally 8 nodes in the system. So here is the example, the GPU skill. So we can have 2 single width GPU or FPGA in the slate. As you can see, as I just highlight, this is scale-out architecture. So today, actually, in the data center, the compute already, the scale-out compute is the mainstream in data center, right? So most of data center, they just use the 2-socket, Intel 2-socket compute node, high density node in one rack. So you need to serve more workload. You just add more compute node to the rack. This is a pure scale-out architecture. So as you can see, our design is ideal for scale-out deployment. If you have increased inference computing need, you could add more nodes to the workload. If you have different application demand, they can be provisioned to different nodes, same hardware, but run provision for different application. For example, you can have one speech recognition node model with TensorFlow on node 1. image recognition with cafe on node 2, multiple object detection on node 3, and so on. An issue that some users might have is that they may not be familiar with deploying inference workload in a cluster environment. So if you want to test out this system, it may be difficult to hit the ground running. At QCT, we create a reference design that could be used as a turnkey solution to help you to facilitate that process. For example, Kubernetes is a popular platform for managing containerized workload and the servers that facilitate both configuration and provision. Our reference design demonstrates scale-out inference with integrated hardware and software. We took one node. Later, I will do a live demo. Actually, that's a video which took in our lab. Due to the power constraint in this room, so we just made a video later to show to you. We took one node, as you can see here. There's one rack. We put a lot of our 2U system, and each system we have a node, right? So we take one node in the chassis to function as a Kubernetes master, load balancer, and the client to issue inference request. In real data center deployment, typical master would probably be a complete different 1U, 2U servers. But for simple validation and POC, we just use one of the A node as a controller. Right? And this will help keep the footprint small for easy of use. The rest of 7 nodes, each node receives image through a 10 gigabit network. And then we can inference on Intel's FPGA. I will demo the FPGA first. The FPGA software stack is enabled with Intel OLA IP and the OpenVINO. You can check Intel website for more detailed information for those DLA IP and the OpenVINO support. And we use Google Net Inference Web Service container. We also create reference design for GPU. We use NVIDIA T4 GPU in each node. The enabled software stack is NVIDIA's Tensor RT Resonate 50 Inference Web Service container. I would like to show a demo using this inference design so you can see the performance scale out. So this is FPGA inference. So there are total, I think, 7 nodes. So I will click and start. So the workload, when the workload increase, they will deliver to different nodes. This is a video which taken in our lab. So you can see that's per second how many image inference on one FPGA. So this is the This is one of the 7 nodes. So you can see we have an E3 here. And this is Intel FPGA. So this is one of the configuration. And actually, we can put another SKU, for example, another 2 GPU on the other sled. So end up with, of course, there are only 4 nodes. Reduce the node count to half, right? But each GPU can have 3 FPGA maximum. So, but in the demo, we just use one FPGA for 1 CPU. So you can see, so the workload are evenly, on each node. So totally up to now is around 7,000 image service divided by those 7 nodes. Okay, by the way, the FPGA, regarding FPGA, this is everything start from the scratch. Of course, we get the support from Intel, right, on the software stack. Start from the scratch. So we program the FPGA by ourselves. We use the IP from Intel. So, and also Kubernetes container. This is all done by ourselves. And that's a FPGA. Later, you will see GPU. My goal is not to compare the performance among those 2 different solutions from different people, right? Because it's not an apple-to-apple comparison. We use different generation. We probably use older generation on one of those products. So the comparison, does not mean much. So this is the GPU. You can see the GPU got the higher performance. But again, I would like to highlight that again. There's not much meaning for the comparison because we have not optimized on the FPGA yet. Yeah. It's kind of a rush to prepare for this demo for OCP. My engineer only spent 2 weeks doing this stuff from the scratch. Of course, we got a very good support from Intel. So this is T4. Again, we know recently there are a lot of research talking about today training is a scale up, right? So you can see DGS1 got the 8, DGS2 got the 16 GPU, right? But again, we all know when you use scale up, the system cost, getting higher because the thermal, power, cooling, everything is, and the fabric connectivity, right? It's quite challenging. So I know there's a trend. People are looking at even the training. Can we use the scale out? But I think that's still early stage, right? But for the inference, I think I would say that should be mature enough to implement scale out for inference. But why there are still a lot of people use the high performance server for inference? Because the utilization rate of the training server, right? If the training server in your data center are idle, why not? You can just use that as inference, right? So I think AI just get a start. Eventually AI will be boom, right? So eventually AI workload become popular, get higher percentage of total workload. At that time, you probably need a dedicated inference hardware, like today, right? Compute, storage, right? They probably dedicated. This is for storage, this is for compute. So our vision is eventually scale out will coexist in the data center. Okay. So that's all my presentation. I think we still have plenty of time. So you can come and take a look at this system. Okay. So I'm not sure how much time we have. 4 minutes, yeah. So maybe you want to ask questions, maybe 1 or 2 questions, but you can come and don't shout. You can take a look at the hardware here. Thank you. Okay.
So, nice talk, thank you. And thank you for using Intel CPUs. Were all your workloads just image recognition, or were you also looking at recommendation systems and other workloads that do better on CPUs?
This is a tough question. I think we can talk offline. If you are really interested, we can. I can invite my engineer to.
Absolutely, I would love.
Yeah, yeah. But basically, we sell hardware, right? Mm-hmm. So customers have their own workload. Most of them are their secret sauce, right? So we just use a kind of standard, workload to validate the architecture. So for specific workload, I think we can, explore more in details. Yeah.
Absolutely. Okay, thanks.
James, maybe we can talk to her later, yeah, okay. Sorry, I cannot answer your question exactly right here.